Okay, in a previous video, I classified these triangles over here on the left-hand side by their side lengths. So I classified them as either scalene, equilateral, or isosceles. In this video, I'm going to classify them instead by the interior angles that they have. So I have a couple of different options. The first one is the obtuse triangle. And obtuse triangles are triangles that have at least one obtuse angle. Now, the problem with this idea with what I just stated is the fact that the triangles, the sum of the angles inside of a triangle add up to 180. So, for example, here's one with an obtuse angle. If this one's over 90 degrees, that means that I have at least 90 of the degrees spoken for out of the 180 within the triangle. These other two guys are going to have to be pretty small in order to still have only 180 out of all three. So you can see here that maybe the statement instead should say they have one obtuse angle. In other words, you're never going to have more than one. It's going to be impossible because there'd be too many degrees. You only have 180 to work with. So if they don't have an obtuse angle, then we can say that they have three acute angles, or we could say that they have 0 obtuse angles. And either way, we would be classifying a triangle as acute. This leaves us one other classification, and that is the case that doesn't have, let's say, in between the obtuse and the acute, which is greater than 90 and less than 90. We have the example of the right triangle, probably the one we're most familiar with, and the one that we do the most stuff with, because that's where we use Pythagorean theorem and stuff like that, SOHCAHTOA. And this one has a 90-degree angle, a right angle. So if I'm going to go through, I'm going to classify based on their angles. I'm going to call it a triangle either obtuse, acute, or a right triangle. Let's go through some examples. In this case, if I were to use a protractor, I would notice that all three of these angles are less than 90 degrees. Really, those two are the easy ones. We can see obviously that these are. It might help in some cases just to rotate your paper. And if you rotate the paper, you can see now that that one is obviously less than 90 degrees here, right? So all three of those are definitely acute. No obtuse angles, therefore I can classify this as a, let me straighten out my paper, there we go, as an acute triangle. Over here, I can see that all three angles are the same. Well, that's interesting. Let's see, I have three angles, they're all the same, and they add up to 180 degrees. The only option I really have is if this one is 60 and 60 and 60. That's 60 times 3, which is 180. That means all three of those are also acute angles. Now, we come across a special case here. When all of the angles are the same, and I didn't put this over on the side, but this is a special classification. Not only are they all acute, so they're acute triangles, this is an acute triangle, but we can also say that this triangle is equiangular. You might want to take a second here and pause the video, learn how to spell that. I believe I spelled it right. I guess I said that, and now I don't know if I spelled it correctly. But all that means is you can see equa here, which means same, angular, right? Same angles, all of them. So what I want to point out is the fact that when we classify by angles, a triangle can be in more than one classification, and that's not a big deal. Okay, down here, you can see the way that I've drawn this. I have two pretty tiny angles here, but I have one angle that is obviously larger than 90 degrees. Therefore, this is an obtuse triangle. This triangle looks a lot the same. In fact, I just took off the tick marks. But it does have one obtuse angle, two acute, but we don't care about that. We know we're not going to have more than one obtuse. Because it has an obtuse angle, though, it's an obtuse triangle. Down here, the way I've drawn this triangle, two of these are the same. You can see that those are less than 90 degrees. This one is obviously less than 90 degrees as well. 0 obtuse angles. This is an acute triangle. This one, all right, it's an equilateral triangle. It doesn't have any angle markings. I can tell, though, that this one is less than 90, and that one is 2, and that one is 2. And if I need to rotate my paper in order to see that, I'm going to do that. So I know that this thing is acute, but here's the deal. Based on this idea of the Hinge Theorem, H-I-N-G-E, I know that a side length is directly related to the size of the angle across from it. So I can say that these two sides, this side and this angle, are related. I know that this side and this angle are related. And if this side is the same as this, that means these angles across from them are the same as well. And if this side is the same, that means the angle across from it is the same as well. And so it turns out that if I have an equilateral triangle, all sides the same, I also have an equiangular triangle, all angles the same. So this is another one of those that meets two classifications. Not only is this triangle equilateral, but is equiangular as well. Last two triangles both have this little square. That tells us that that is a 90-degree angle. And when they have a 90-degree angle, we classify these as right triangles. So now, if you put the last two videos together, you can see here that all these different classifications can be made either based on side length or angle. So I can call a triangle like this, it's a scalene acute triangle. Here's an equilateral equiangular triangle, although to be honest that's a little redundant because we know that every equilateral triangle is also going to be equiangular. Here's an isosceles obtuse triangle, so on and so forth. Hopefully that clears up classification of triangles based on either angles or side lengths. And if you have more questions, ask them in class or shoot me an email.